Assalamualaikum and good morning. My name is Muhammad Syazwan Hakimi. I would like to present about chapter 5, which is low pass filter, and the task given to me is assessment 1. I need to first question, I need to sketch the ideal filter. This is ideal filter and this is actual filter. At actual filter, we got a little bit ripple for the pass band and the stop band. And after that, for the question 2, we need to first thing first. If we want to find the coefficient, we need to do normalization, which is we need to normalize FPN, omega PN, theta FN, theta omega n, FSN, omega SN, FC, and omega FC. Next, we need to find AS, N, and alpha. AS, which is attenuation stop band. The question given 45 dB and it's near to the Henning. So Henning 44. So we can use the formula from Henning. We get this formula from the appendix, and we need to find the n. To find the n, we just use this formula and swap, and we got 31. And when we got n, we need to find the alpha, and we got the alpha. And for the third step, we need to refer the table 1, which is we got the alpha 15.5. We get the decimal point, which is n not equal to alpha. So we need to use this formula from the appendix. And after that, we can use this to find the coefficient, which is hn equal to hdn times with omega n. So we just need to use this formula times with this formula, and we can replace the omega c here, replace the omega c to cut the fc and 2, and after that we got the general equation this. And next, for the third question, we need to find the causal FIR from n32 to 34. So from the general equation, we just need to substitute the value of n, which 32, and we got this value, and substitute n with the value 33 here, and here we got this value, and substitute the value of n which 34, 34, 34, 34, and we got this value, and the total of the hn, we got this value, this value, which is this n equal to 32, 33, 34. Thank you for the listening.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Eka Guzairi. So I will take assessment 2 for my presentation. So what we want to find. So we have first question is determine the selective factor K, discrimination factor D, and filter order N. And the second question is determine the 3 dB cut-off frequency omega C to any value within the range. And 3 is determine the system function based on the calculated left-hand side poles. And the last we see the coding and the. So first question we give a RV less than 27 dB AS equal to more than 40 dB. Omega P is equal to 0.3 pi. Omega S equal to 0.5 pi. So we went to find the K. We use this equation, omega P over omega S. So we get 0.6. When we find the D, we use the square root 10 power of RP over 10 minus 1 over 10 power of AS over 10 minus 1. And we get for D, we get 0.2237. On the N, N is a You can see a more than log 10d and log 10k. Since we have find the k and d, we just sub into it. So we get like this, and the answer is n more than 2.93. So for the stabilized filter, we must use integer or number bullet. We use a 3. Next, we calculate the allowable range for our 3 dB cutoff frequency, omega c. By using this formula, we just sub into and change the 10 RP10 AS 10 AS over 10 to the equation, and the final answer is 2.66 less than omega c less than 7.29. To ensure a balanced and stable design, we select a clean mid-range value of omega c is 3 dB. So for the last part is finding the left hand side poles with our filter order n equal to 3 and cut off frequency omega c equal 3. We calculate the stable left half plane poles of the transfer functions using the standard Butterworth pole formula. Using this method to evaluate for k 0, 1, and 2, we get for k 0, get a minus 3 signs, multiply with omega over 6 plus j3 cos, multiply with omega 6, and we get the final answer is negative 1.5 plus j 2.598. For S1 is S1 minus 3 sign multiply with 3 pi over 6 plus j 3 cos multiply with 3 pi over 6. Then the answer is negative 3. And for S2, we get negative 1.5 minus with j 2.598. The final answer, we just sub our answer. Okay, like this. So negative S0 over S minus S0 multiply with negative S1 over S minus S1 and multiply with negative S2 over S negative S2. And the final answer, we get a 2.6.99 over S plus 1.5 negative J 2.598 multiply with S plus 3 multiply with S plus 1.5 J 2.598. Now we furthermore to the we go to the MATLAB part, the coding part. By using this coding, we get a multiple response and face a response. We will answer like this. And that's all for me. Thank you.